Hello, this is Praveen Kumar Sinha. I welcome all aspirants of Quantum GIS. This session is focused on understanding the Quantum GIS or QGIS. This is not like that I am an expert in QGIS. As a matter of fact, hardly a few months back, I started exploring QGIS with an experience of GIS projects carried out over proprietary and open source software since 1997. When I started exploring QGIS, my approach was to understand it in a comparative term. What was there in the other GIS, and same is present in this GIS as well. Of course, this GIS has all feature richness to be called this GIS an enterprise GIS. This is the resemblance aspect made this GIS understandable to me. And I hope a beginner or a novice in Geographic Information System will also develop a rapid understanding with the QGIS. So let us start with downloading QGIS. Put down QGIS download in a browser's search engine and activate the search process. The browser presents a list of sites. Download the platform-specific suitable binary package for QGIS. QGIS installers are available for Windows, Linux, but we will be restricted our operation on Windows. Prefer the site what is prescribed here, https://en/site/for-users/download.html. On completion of our download, the installer binary may be available in Systems Download folder. This binary bundle needs to be double-clicked to start the installation of a QGIS. Permit the system's firewall to install QGIS. If any alert is thrown that an earlier version exists on the system and it needs to be uninstalled, so okay this alert. To proceed with the uninstall wizard, prefer the next button on the wizard. Allow the installer proceed with the thrown dialog boxes by okaying, preferring next over back options and accepting the license agreement. Accept the license agreement and check the choose component, that is QGIS, in a dialog box to install it. Uninterrupted installation starts to take place. At this stage, one can have only one option available to see the progress in a progress bar. Wait while installation takes place. On completion of installation, the system notify you the finish of the installation. You need to accept the finish. Now launchers will be available on your desktop. You have to launch by double clicking the icon, and sooner the launching process will start. On completion of launch, the first look of the project template will be available to you. The first look of a project template of a QGIS on launch is a complex of interfaces. A user needs to understand the components of this complex. First row of the whole frame informs the project on which the work is in progress, if named, otherwise untitled project. Second row is a menu bar. Activity dependent submenus are approached through the main menu for project, edit, view, layer, setting, plugins, vector, raster, database, web, processing, and help. Beneath the menu bar and aligned to the left arm of the frame, the GIS places the toolbars. The toolbars may occupy themselves in single or multiple rows. It is advised that as a beginner, one should preferentially restrict the number of toolbars based on session-specific operation on data layers. The GIS places a few panels along the left and right arm of the project frame. Most important among them is data browsers and processing toolbox. A wide blank area positioned between the lower frame and the top panel for toolbars. The white blank area is the map view window. This represents a Cartesian space or an Euclidean space where maps are plotted and based on the red data on coordinates from a vector file or row and column values from a raster table tagged in browser. A current position of the pointer in map view window is constantly reported in a midway placed small window along the lower edge of the project frame. Lower right corner is a reserved position for a smaller window where EPSG code depicts the projection for the first map opened in the map view or reprojected displayed view or project defined view. The gist of the previous screen is that a GIS, and so Quantum GIS also has a Cartesian space defined over its display device and a database. Database supply the coordinates in terms of x, y, and z values or the desired spatial data tables or ground sense digital numbers saved in matrices to get plotted over the display device of a GIS for viewing by the users. The spatial data readings is not one way, that is, database tables and matrices to the screen plottings, but it is reciprocal. Reciprocity between plot and record is maintained by a manager of the GIS software. The interactivity between database and display device is managed through algorithm underpinned the data browser, menus, tools, projection, and other manipulations through a pointer in a desired way by user. The GIS manager is supplemented by components, the set components. The manager has access to libraries of symbols, projections, etc. When desired by user, the manager refers libraries, make the data of a library available to user to set the desired depiction. A number of plugins are available with the URL of the official site of QGIS. Some of them are bundled with the installation binary setup, whereas other could not be bundled. But the QGIS provide opportunity of availing the use of these plugins by installing them. Some purpose-specific algorithm which could not be bundled in installation binary is made available as plugins. QGIS has a long list of plugins which can be installed during a session. For exercises we carry out during practical sessions may require the following: Open Layers plugin for access of web resources like Google Map, Bing Maps, OpenStreet layers. Google Earth Engine, which integrates QGIS with the Google Earth Engine. Google Earth Engine data catalog. Then geometry attribute table. Then lat long tools. Other plugins may be QGIS, import photos, and toolbar generators. The plugins are installed by a pop-up dialog box at menu path, plugins, manage and install plugins, plugins not installed. Selecting the desired one in the dialog box and clicking the install button. This slide shows the final stage of installation of a QGIS plugin, where one dialog box is on the screen, and here one can search with the initials of the plugin name in the list of non-installed ones, and installation button is at the lower right corner to install the particular plugin into QGIS. The resources of Google Earth is frequently used in projects of users. After installation of Google Earth Engine and GE catalog, they require authentication. The following slides describes the process. The authenticator throws a browser window to sign in with Google through Google Earth Engine Python Authenticator dialog box to choose an account. Here, the user needs to indicate a mail account from the list. On indicating an account, the authentication process moves ahead. The very next window is allowing the mail account being tagged with a session of a QGIS by the user. So here, user needs to allow the screen. In next screen, the authenticator issues a code, needs to be copied by the user and pasted in appropriate text box for completion of the authentication process. Next is in 4 steps, the API code is made active. First step is copied code is carried to the launched session of QGIS. Then second step is menu path, web, open layers plugin, Google Map is followed to reach the change API dialog box. Pasting over or overwriting on the code of a previous session, the code in memory into API key dialog box. And then fourth step is okaying the box. This is the process of authentication into the system to get the maps of Google Earth into our session. There are some other easier methods to achieve Google Earth maps on sessions of QGIS, which will be explained into next slides. At an earlier instance, it was advised that the number of toolbars needs to be minimized. This process is customization of toolbars. Let us see how customization is carried out in QGIS. This slide is to understand why customization is required for toolbars. So here you can see that the toolbars occupy a large portion of the screen and small work area. To improve the work area, we need to reduce down the tools, and in that process the customization becomes important. We have seen that the project template was had occupied three rows of toolbars and one side column, left side column was occupied by toolbars. Here in this panel, in this screen, we can see that it is reduced down to 1.5 rows of toolbars. How it is customized, we need to go to view menu, toolbars submenu that invokes the panel of the list of toolbars. We need to check those toolbars which is required at this stage or at a beginning stage of learning GIS. Digitizing toolbar, map navigation toolbar, selection toolbar and snapping toolbar will be sufficing the purpose. Advanced customization may be carried out by QGIS toolbar generator, which is a plugin, needs to be installed first. Then it has to be checked in view toolbar menu. Thereafter, one tool will be generated at which is shown at point 4 on screen, and on clicking this tool, one panel which is depicted as 5 will be generated on screen. This is a toolbar manager where its right panel displays all tools available in the software. We need to select a tool at 5.1 action, then 5.2 action, click on the plus button, which will drive the selected tool to left panel, the panel 6, and one list will go on get created in panel 6. So 5.1 action, 5.1 and 5.2 action has to be carried out several times, and finally one list will be available at 6. And 6.1 activity is carried out through the 4 buttons to drive the selected tools up and down with the separator and removal of a not needed tool from the list. And finally, at the 6.2, it needs to be saved to a file, and that file has to be read from the saved one. So by carrying out this operation, we will get an advanced customized toolbar. The file generated is now enlisted with the panel of toolbars, and that needs to be checked. Here on this panel, one can see that PK Sinha digitization environment related tools is got created with the previous exercise. Beside that, QGIS advanced toolbar generator and snapping toolbar is selected. And then now in the background you can see that the tools are reduced to one row only. Sometimes the launch of a new session in QGIS notifies that some of the plugins are not activated or not loaded. So it throws one notice at its first window. Here it has given that opportunity to enable those plugins activated from the first screen itself. The slide depicts a screen of a QGIS with customized toolbars, which has caused an availability of a wide map view area. Now our focus is getting switched from toolbars to panel invocation. Panel invocation is carried out through view and panel menu, which leads to a list of panels available with the software. As a beginner, browser to layer styling, layers, processing toolbar, toolbox. These panels will suffice the purpose. After checking these panels, we can see browser 2 at 5, layer styling at 6, and processing toolbox at spot 7. Here is the another method of reading the Google Map resources, but not from the menu path. It is now from browser 2. At browser 2, we have reading ability of data from system drives and databases beside websites. Here we have one item, XYZ tiles. On right clicking this tile, it throws one dialog box where name and URL needs to be supplied by user. Some of the name and URL are being provided at a list of 5. On supply of the name and URL, corresponding URL, and okaying the dialog box, the available resources of that particular URL will be tagged with XYZ tiles. And on double clicking, any layer of that resource will tag the layer to the layers panel. Here is another method of referring the free geometric resource on web. It is getting done by Quick Map Service, which is a plugin, requires installation and empanelment of the search QMS. The panel search engine, if one gives a search word for the area concerned, it fetches different resources available with free geomatics, which can be added to the panel of layers under study. QGIS allows GPS mapping. It requires empanelment of a GPS information panel and configuring the panel for mapping purpose. After completion of GPS mapping, disconnect the GPS panel. Layer subpanel of browser 2. It corresponds to the table of content of ArcGIS, where layers of a drive web resources are tagged for project area. This panel allows the behavior and property of a layer and the feature or elements of layers, which is viewed on the map view window of a display device. The tag layers may be web layer, raster layer, vector layer, a virtual layer, or a table. This screen illustrates a virtual layer which has no root. This may be created by the user or result of a process. If found useful, may be saved into project. This slide depicts the appeared panel on the right click of a selected raster layer. Layer behavior and properties may be changed through the items of this panel. This is to show the appearance of a panel on a right click of a vector layer, which controls the behavior and properties of a vector layer. This slide depicts the nature of a map view window or display device of a GIS. This represents as a Cartesian coordinate space, which has four mathematical sectors, each of 90 degrees, and a combination of a positive and negative effective sides of x and y axis. Conventionally, geographic referencing is carried out on a 3D curvilinear surface of Earth by intersection of a longitude and a latitude lines. These angular referencing components are acquired into a GIS system as if Earth is flat and the origin of the Cartesian space coincides with the intersection of a prime meridian and equator. The plotted angular values in degrees play a role in relocating the feature to a measurable unit of length through mathematical equations using the Earth's parameter, that is a radius, sphericity, etc., to fit into a two-dimensional surface. Actual feature on curvilinear surface may attain a little distortion in plotted feature. One or a combination of distortion in shape, area, distances, and direction may occur in process of projection from a 3D to 2D plane. Varied type of projections are there within three main types: cylindrical, conical, and planar. GIS manages these projections by providing a code called Spatial Reference Identification Code. With this code, it manages the equations and parameters of Earth's shape and dimensions. This code also regards the agency, body, or individual who formulated the specific projection and its equation. Small window in a lower right corner of the project template of QGIS depicts this information with the EPSG, which stands for European Petroleum Survey Group, the projection formulating body. Lambert introduced the transverse Mercator in 1772. It uses a horizontally oriented cylinder tangent to a meridian. Most zones in UTM spans 6 degrees of longitude, and each has a designated central meridian. This is particularly useful for mapping large areas that are mainly north-south in extent. Now we have reached to the concluding slide. On the basis of first reconnaissance on QGIS, it can be said that QGIS is a feature-rich open source enterprise GIS. This allows to view and handle vector, raster, 3D, spatial databases, and virtual layers. It has a wide repository of plugins to assemble the required ones at the time of need. The GIS is rich in tools and panels to carry out a project activity smoothly. Scope of customization is also available. It has a built-in support to connect the local hard drive, RDBMS, open geometric resources on web to acquire them into the project for interaction of layers and background spatial reference. Display device of a QGIS manages online projection to provide the overplotted view of thematic maps projected differently from its source. Thank you.